We need to keep two things in mind here. One, Newton's first law of physics, and two, the booster's propulsion gases must be concentrated in the bottom of their tanks to ensure proper pickup and mixing downstream without contamination from uncombustible gases. Now, keep an eye on the fire suppression gases being ejected from the engine compartment area of the booster. And remember, all gases inside and outside the booster will behave or move the same. Frame A. Just prior to hot staging, the fire suppression gases appear to be streaming behind the booster, which is what you would expect to see if the booster was increasing speed with respect to the ejected gases. The booster is accelerating, and its propulsion gases are forced to the bottom of the tanks. Frame B. At hot staging, the fire suppression gases appear to be streaming straight out from the booster, which is what you would expect to see if the booster was moving at the same speed as the ejected gases. The booster is not accelerating, and its propulsion gases are stable in their last position, presumably the bottom of the tanks. Frame C. Final phase of hot staging. The fire suppression gases appear to be streaming up the booster, which is what you would expect to see if the booster was moving backwards from the ejected gas. The booster is accelerating in the opposite direction, and its propulsion gases would be migrating to the top of their tanks. With that, you might find yourself trying to restart or operate your rockets with a mix of combustible and non-combustible gases. I would think that would be a good way to blow up a rocket's turbo drive system. I suspect they've got to work on keeping the propulsion gases at the bottom of their respective tanks.